Hello, this is the second chapter in our book. The book that we've been using in this course is Understanding Pharmacoepidemiology, and chapter 2 title is Principles of Epidemiology Applied to the Study of Medication Use. The outline of this chapter is big number 1 is overview of epidemiology, then types of calculation. Then we move into number 3, which is measures of measuring mortality. And then number 4, we have measures of association, relative risk, odds ratios, etc. We will not cover the measures of association as per the book. The book is very brief. What we will do is we will have a separate lecture where we will talk specifically and in details about the relative risk, the odds ratios, the methods of calculation, how they're calculated depending upon the design, because I want to give you a very good understanding of these measures of associations. Also, we will do calculations, and we will also do calculation with confidence intervals, specific interpretation, and later on, as the course progresses, we will adjust the relative risk and the odds ratios based on some missing data or misclassification, and therefore it's important to spend some time on these measures of associations. So as an overview, epidemiological studies are conducted to examine the frequency and distribution. So I have mentioned this before, that epidemiology is the study of the occurrence and the distribution. So occurrence in terms of space and time, and distribution in terms of risks of the diseases in group of people, to determine the cause of our risk factors for this disease, and to evaluate the effectiveness of preventive and therapeutic measures to control the disease. We have mentioned previously that epidemiology has two large arms. One is infectious disease epidemiology, and the other is chronic disease epidemiology. For infectious disease epidemiology, there are 5 basic principles or 5 features of infectious diseases. One, the cause of the infectious disease, its presence of a single known identifiable cause. Like it could be a bacteria, it could be a parasite, it could be a virus. One, only one, and this is the only one that is caused, and you have some sort of a one-to-one relationship between the cause and the outcome. Second, the transmission is mostly one-to-one, direct and indirect. So it could be animals and insects. So one-to-one, this is one infected person infect another person, that's one-to-one. And direct and indirect also come in the principle of a single point versus a multiple point. Number 3 is asymptomatic, can still be at risk for others. So a person without symptoms can still infect other people. And number 4, people that get the disease develop immunity, most likely. And the last thing is that vaccination can protect individuals and community. Now, you will notice that these principles do not apply for chronic disease epidemiology. So in chronic disease epidemiology, obviously the leading cause of death nowadays in the chronic diseases, you probably already know that heart diseases are the leading cause of death, followed by cancer, stroke, chronic lower respiratory disease, and diabetes. Features of chronic disease epidemiology. So one, the cause, if you compare it to infectious disease, it's not a single cause, it's more complex. It's number of risk factors that combine together, which we will probably discuss a little bit more when we talk about causality in this course. So it's not a single cause, but there is but each is independent on the predictor. Number 2 is transmission. The concept of contagion does not exist in chronic diseases. However, there could be some genetic factors that predispose people, or environmental factors that predispose people for certain diseases. Number 3 is disease progression. It's lengthy with a preclinical or asymptomatic phase. Early detection and early treatment is crucial. If you remember, in public health, we talked about health promotion and disease prevention. ولما حكينا عن disease prevention حكينا على primary, secondary, tertiary. So these concepts kind of like apply as well. intervention to manage chronic disease must be persistent and long term. So it's not you come, you get an antibiotic, and it's done. It's a long term, and you already know all of this. But the thing is because of the nature of chronic diseases, the methodological tools used in chronic disease epidemiology will be different as well. So curability, mostly people, it's incurable and detrimental to life expectancy and quality of life. Management of disease includes slowing down the progression, preventing or delaying complication. Um, and therefore, the growth of epidemiology, it started as a systematic observation of natural occurrence of diseases. It moved then into finding the cause and the risk factors. So causes and risk factors basically can about infectious diseases. They do apply for chronic diseases, but more what now it is about, it evaluates measures to prevent and control diseases. And therefore, pharmacoepidemiology applies concepts and methodology of chronic disease epidemiology to studies of drugs in population. In epidemiology in general and pharmacoepidemiology, there are certain types of calculations that are done, and we're going to focus on rates, ratios, and proportions. Hopefully, you've seen this before, so we're going to go over them briefly. So the first one is um, rates. So what is a rate? It's a frequency with which an event occurs in a population at risk during a determined time period. A rate is comparison of two numbers, and it has four components. So in the numerator, you put the frequency of the event, يعني how many نقول myocardial infarction. In the denominator, you put the population at risk of that event. You will delineate it in a specific period of time, and you usually use a multiplier so that the number makes sense. So for example, infant mortality in the USA for the year 2006 was 6.69 per thousand live births. So in the numerator حطينا infant mortality, how many died. بالdenominator حطينا live births, and the specific period of time is 2006, and the multiplier was 1,000, so that when we're reading it, it's easier to read. It's easier to read 6.69 per thousand than to say 0.00669. The second one on the list is a ratio, and a ratio is simply comparing two numbers. These two numbers do not include one another, and a ratio can range from 0 to infinity. So for example, فينا نقول the ratio of women to men in the US is 143 million to 100, I think it should be 138.3 million, and therefore the ratio is 1.04. So the women on top, and the denominator حطينا المن. Okay, so that's what a ratio. So when we say like the ratio of something to something, the numerator does not include the denominator, and the denominator does not include the numerator. Proportion is also a division of a number by another. However, the numerator and denominator are related in this case. The numerator is always part of the denominator. It's like a percentage. Okay, so we express it as a percentage, and it raises from 0 to 100. So for example, proportion of AMI patients without beta blocker contraindications who are prescribed a beta blocker at discharge is used as an inpatient quality indicator. So that brings us to the second part of 2.2, which is measuring morbidity. So measuring morbidity, as a definition of morbidity, you may have remember what is disease from the definition of WHO. It's departure from state of well-being, mental, physical, and social well-being. In this book, morbidity is defined as any departure, subjective or objective, from a state of physiological or psychological well-being. And therefore, morbidity is sickness, illness, or morbid condition. And there are two types of basic measurement to assess the morbidity in a population, when the incidence and proportions. Starting with incidence. So what's the difference between incidence and prevalence? Incidence measure the occurrence of new cases, ML prevalence measures the number of cases of a disease already present in a population. So what is currently happening is prevalence, whereas meaning in new cases that will show up in the following year, that would be incidence. Okay, so incidence in the new, prevalence in the new will all together. So incidence defined as a number of new cases that occur in a population at risk of developing the disease during a specific time period. Individuals at risk are initially free of the disease. So you start with people that are free, but however, they are at risk. And it's expressed for common disease as a percentage or a number of cases per thousand population. For rare diseases, usually expressed using a larger denominator, so we talk about, for example, 100,000 population. This is for incidence. Now, there are two types of measurement for incidence. There is the cumulative incidence and the incidence rate. هنحكي عن كل وحدة in a brief manner. So cumulative incidence measure the proportion of the population at risk that develop the disease of interest over a specific period of time. So follow-up is observe the entire duration of the follow-up. So everybody has to be part of the follow-up for the entire period. Okay, that's the first difference between cumulative incidence and incidence rate. Everybody has to be accounted for the entire period. The period of time usually is 1 year, and the concept is risk. So, كمان that's a very important point to keep in mind is that cumulative incidence relates to the concept of risk. Sometimes we refer to it as incidence proportion, and what you require is a fixed population. يعني in-migration والout-migration are equal لبعضهم البعض, and there's no loss to follow up. So the formula for the cumulative incidence and the number of new cases مثل ما قلنا, very importantly, during a specific time period, so we're tying up to the time, divided by the number of people at risk. كتير مهم إنه you divide by the number of people at risk developing the disease during that time period. So basically هولي اللي بيكونوا بالdenominator منهم the new cases are going to emerge and they're going to appear in the numerator. Okay, so you may have 1,000 people, and during that year, out of the 1,000, لنقول 150 developed this new disease. So the cumulative incidence would be 150 على 1,000. Okay, so the numerator and the denominator must be measured for the same defined period of time. Example, 80 obese people were part of a 12-month program. At the start, 60 were diabetic-free. During the program, 6 developed the disease. If we're asked to calculate the cumulative incidence, then you know that the new cases, remember, you're just going to put the new cases. So in the denominator, you're just going to put the 6 that developed the diabetes in this 12 months, and you're going to divide by the population at risk, يعني the 60 only, not the 80. Okay, لأنه 60 only were free, 20 already had it, they were not part of the calculation, we're not going to look at them, and therefore your cumulative incidence is 10%. So over or 100 per 1,000 participants during the 1 year period. Okay, that is your cumulative incidence. So why incidence rate? Population is dynamic, so different individuals are followed for different period of time. So let me start again. So كنا عم نحكي نحن على cumulative incidence. هلا بدنا نحكي على incidence rate. What is the difference between the two? Remember لما كنا نحكي عم نحكي على cumulative incidence, we said that a very important concept is that the population has to be the same population. However, this is not always feasible, and therefore we need to do something else, and that something else is the incidence rate. Also, we call it the incidence density. The concept that it measures here is how fast new cases of a disease are occurring, accounting for varying time for different individuals. Whereas the concept with the cumulative incidence can risk hone how fast it is spreading, how fast the disease is occurring. And if you look at the formula for the incidence rate, It's the number of new cases of disease during a period of time, but this time you're dividing by a concept called total person time of observation in a population at risk during that period. So في عنا concept اسمه person time يعني every person multiplied by the unit of time that they participated during the observation period. هنعطي example to make it easier to understand. So in this example, we have a follow-up of 5 years, and I have subject A, B, C, D, and E. And you will notice that not everybody was followed for the same amount of time, nor were they followed up during the same number of years. So subject A was followed right from the beginning till the 3rd year, and then that subject was lost. We don't know what happened to that subject. Subject B, the follow-up started the 1st year and ended the 4th year when they actually developed the disease. Subject C, كمان, it started the 1st year and ended the 2nd year when they developed the disease. Subject D was developed for the entire period, and subject E was followed up only for from year 1 to year 5. So if you look at the first person, subject A, the follow-up was for 1, 2, and 3 years, and therefore subject A participates for 3-person year. Subject D كمان 3-person year. من year 1 ل year 4 3 سنين 3-person years. Subject C 1-person year. Subject D 5-person year, and subject E 4-person years. Knowing that, now that we know everybody for how many person year they contributed, now you can add up the person years. So 3, 3 and 3 and 1 and 5 and 4, that's a total of 16 person years. So when we come for the calculation of the incidence rate, what we need to put on the numerator the number of new cases اللي هن 2, 2 out of the 5 developed the disease, and then what you're going to divide by the total person years. How many person years we had? We had 16 person years, and therefore you're going to get an incidence rate of 0.125 per person year. Yani we say about 12.5% of the patients per year would develop the disease of interest among patients similar to those in this example. Okay, which is quite different from cumulative incidence. The time unit that is usually used in incidence rate could be year, could be month, or even day. It depends on the nature of the disease and the study. For diseases that take a long time to develop, such as diabetes, person year is commonly used, whereas for diseases that develop rapidly, such as influenza, person month or person days are used. Then the author is going to discuss a little bit the incidence rate in large population, and what he's saying that calculating person time for large population using person can be impractical, difficult. So the solution to that is to multiply the average size of the population at risk by the average length of time the population is under observation. Also, when few people develop the disease and the entire population remains stable during the period of observation, the average size of the population at risk can be estimated using the size of the entire population. Yani, for example, to make things easy, the incidence rate of breast cancer in women in 2006, it is the total number of new breast cancer cases in 2006 divided by the total number of women in 2006. Then there is the concept of prevalence. Like in incidence هن the new, prevalence هن the existing cases, the old and the new. And when you're calculating the prevalence, in your numerator, you're going to put all the individual must have the disease of interest at the time of the assessment. For this figure, you will see it a lot published. And this is saying that prevalence هن كل الموجودين. What is adding to your prevalence in the incident cases لما they occur, they add to the prevalence. What takes out of the prevalence in those that die, or maybe those that actually get better, they're healed, بيطلعوا برات the prevalence. وإذا في reoccurrence, then they're gonna go out and come back again. Okay. There are two types of prevalence. في عنا شيء اسمه point prevalence and period prevalence. Point prevalence is the number of persons who have the disease at a specified time divided by the number of persons in the population at that specific time. Yani point prevalence could be thought of as a single snapshot in a very narrow point of time, mean عنده disease divided by the population, and it can be expressed as a percentage or a number of cases per 100, per 1,000, or per 100,000, etc. Whereas the period prevalence, you're going to look at a longer period of time. So it's the number of persons who have the disease at any time during a specific period, specific time, divided by the number of persons in the population during that specific period. Okay, so anybody who contributes to that specific period of time is accounted for. The numerator includes cases that were present at the beginning of the period as well as cases that developed during the specific period of time. وهلا بنطلع على example to see how we use it. Period prevalence can be thought as a series of snapshots, and period prevalence can be calculated for week, month, year, decades, depending upon your interest as a researcher. Okay. Now, if you're reading literature and they talk about prevalence without specifying, most likely they're talking about the point prevalence. So here's an example where you have 10 new cases of illness over 15 months in a population of 20 people. Okay. So the way you're going to read this is the following. A downward arrow is the date of onset of the illness. A plus معناتها the person died, and an up arrow يعني the person recovered. And the period of interest starts in October 1st, 2004 and ends in September 30, 2005. Okay. وعندنا 10 أشخاص 1 2 3 or all up لل10, and for every one of them we have the date when the disease started and the date that they either recovered or they died. So if I want to calculate a period prevalence between October 1 and September 30th for that specific period, if I want to calculate a period prevalence, مين بدي أحط بالنumerator? Number 1 بفوت بالنumerator لأنه that person was sick during the period. Number 2 كمان بفوت بالنumerator because that person was also sick for a part of the period. خلاص, if part of the period يعني in the numerator. Number 3 كمان بيدخل لأنه that person was also part of the entire period. 4 كمان, 5 كمان, 6, 7, 8, 9, actually all of them will be counted part of my period prevalence. طب خلينا نغير the period prevalence. If now my period prevalence is between October 1 and April 1, who will be part of my period prevalence? Well, number 1 will be counted لأنه look at the line, it's part of that. Number 2 will be part. However, number 3 will not be part of my numerator. Okay. Number 4 will be part of my numerator. Everybody else will be part of my numerator. If I change my period between April 1 and September 30th, who will not be part of the numerator? Number 2 will not be part of the numerator because number 2 actually died before the study started. And also number 8 also will not be part of my numerator because that person died before the study started. In fact, both of them will not be part of the denominator as well because they will not be part of the population during that specific period. Okay, so what is the relationship between incidence and prevalence? So there are three differences that exist between cumulative incidence, incidence rate, and point prevalence and period prevalence. وهن the type of cases, the type of measures, and the unit of measurement. As far as the type of cases, both incidence rate and cumulative incidence, يعني incidence, they measure or they measure the occurrence of the disease. So the cases are new cases. أما prevalence, whether it's point prevalence or period prevalence, you're looking at existent cases or you're looking at the burden of the disease. When it comes to the type of measurement, cumulative incidence measure the probability that an individual will become ill over a period of time. Remember, we said this is the risk. أما incidence rate, it measures the rapidity with which new cases occur. And finally, the prevalence determines the proportion of the population with the disease over a specific period of time. For the unit of measurement, cumulative incidence prevalence man unit, أما incidence rate, if you remember, that's where we introduced the person time, person years, and therefore it has this unit part of the measurement. Now, how do they affect each other? We're going to start with examples. For example, hypertension, the incidence is high and the duration is long, therefore the prevalence is high. Okay, so عندنا incidence and people stay with the disease for a long period, and therefore the prevalence becomes high. Rosella infantum, the incidence is high but the duration is short. So okay, في كتير ولاد عم يصير معهم روزيولا, but they don't stay with it for a long period of time. They recover fast, and therefore the prevalence is low. Okay, same thing as sudden cardiac arrest. At any point in time, if you come and you measure, it will be low, طبعا, for a point prevalence. Parkinson's disease, the incidence is low, but the duration of the disease is long, and therefore the prevalence becomes high. Therefore, in a relatively stationary population, يعني هالpopulation size ما عم يتغير كتير، ما في outward migration, inward migration, the population is kind of stable, one can write the following formula between prevalence and incidence. You can say that prevalence is almost equal to incidence times duration. So for example, if the incidence rate of a disease is 2%, and the incidence has been relatively steady over the years, and if the approximate duration of the disease is 15 years, the prevalence of the disease would be approximately 30%. So here's an example of further illustration of these concepts. This is a study that looked at a new drug in preventing seasonal allergies in patients who have had seasonal allergies in the past. So عندنا two arms, one arm that was treated and one arm that was not treated. هلا what you need to know is that all 50 treated eventually had reported symptoms, and all 50 not treated, كمان all of them eventually developed symptoms. So where's the difference? Let's look at the results and let's try to understand شو الفرق بين the two arms. First of all, some data مثل ما قلنا 50 in every arm, وقلنا إنه the number of person day كان 700. يعني on average إذا هني 50 واحد and they contributed for 700 person day, يعني فينا نعتبر everyone contributed for about 14 days. At the end of the study, 20% of patients reported having allergy symptoms. آخر يوم من الدراسة كان في 20% with symptoms. يعني the point prevalence at the end of the study in this arm was 20%. So let's calculate the things we learned how to calculate. One is the cumulative incidence. كم واحد كانوا new cases? All of them. Over those at risk, all of them. So عندنا cumulative incidence of 1. أما for the incidence rate, you're going to take the 50 that develop the symptoms, and you're going to divide them by the person days, which is the 700, so you get 0.071 case per person day, and the point prevalence at the end was 20%. If we compare these values to what happened in the not treated arm, in the non-treated arm, كمان all of them got the symptoms at the end of the day, so it was a cumulative incidence of 1, so ما في فرق. However, if you look at the incidence rate, and if you calculate it, it comes out to be 0.12 case per person day, larger than that of the treated arm, and the prevalence rate at the end of the study, the point prevalence was 30%. So what does that mean? Well, مثل ما قلنا, the cumulative incidence rate was the same, يعني ultimately the drug did not prevent seasonal allergies. However, the incidence rate was lower. If you remember, the concept of incidence rate is how fast it spreads. And basically, بما أنه the incidence rate in the treated arm was lower than the non-treated arm, we can talk about is slowing down the onset of the allergy. So those treated, the rate at which they developed the symptom allergy was at a slower rate. So that should implication maybe like if you're in a school, then the spread is lower. So like the demand on the medication or on other medication is lower. On histamine would be lower. On their attendance at school will be different. Okay. And the last one is the prevalence. كمان the point prevalence was lower in the treated versus the non-treated. يعني at any given point in time, in the treated arm, you would had less patients with the symptoms than the non-treated. So that's an interesting example where even though ultimately ما كان في فرق, everybody developed the symptoms, the way the spread was different and the prevalence was different. So how do we use like an incidence and prevalence? Prevalence is used to measure the burden of the disease. يعني for cancer, it helps predict the need of cancer diagnosis and treatment facilities. أنا how many cases عندي؟ كم واحد بدي يكون لهم دواء، بدي hospital beds. This is the burden. أما incidence helps studying the cause of the disease. What are the causal factors and evaluating the effectiveness of program in preventing the disease. Okay, the concept of incidence and prevalence can be applied for the study of the use of drug and the drug effect, and they can be used to measure the drug events, namely in two ways: identifying new users of drugs and measuring existing drug users. Okay, so incidence or prevalence. So there's an example that is presented, and this example is about a pharmacy benefit management company wanted to increase the use of statin medication among members with diabetes or coronary artery disease who had not filled a prescription for statin in the previous 6 months. Then the company delivered education intervention to prescribers. The study showed that 12.1 of the members whose prescribers received the intervention and 7.3 of the control group started statin therapy during the 4 months of the follow-up. And it is said that this is an example of applying the concept of cumulative incidence in pharmacoepidemiology. New users of drug are also referred to as the incident users in pharmacoepidemiology. كمان في case study number 2.1, and this is looking at the prevalence of antidepressant treatment in association to adverse health outcome, including suicide and poisoning mortality. They received data from 3 different places. For antidepressant prescription, they looked at the Department of Health. For suicide and poisoning mortality, they looked at the Office of National Statistics. And for age and sex-specific antidepressant prescribing, they looked at the Health Improvement Network. هول الثلاثة are examples of secondary databases. مثل ما قلنا previously, pharmacoepidemiology uses secondary databases. And so the data is already available. All they have to do is get the data and start analyzing it to answer their specific aim. The study was between 1993 and 2004 in England. The data covered that period of time. Obviously, the study was done afterwards, but they looked back on the data already available. And they started looking at trends. And basically, that's what they observed with regard to the prevalence of the treatment. There was an increase in prevalence in the antidepressant treatment for both sexes over all age groups, with a little decline in the last years for those aged 15 to 24 in both sexes and 25 to 34 in women. I'm going to try to show you the graphs and try to okay, so this is the graph for man. Kill line is a different age group, and going from 1993 all the way to 2004. And what you're seeing is the prevalence of patients receiving the treatment. And you can see like overall, all the lines are going up, 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 with except to this one that's starting to go to decline, maybe. And this line is the age 16 to 24 in men. If you look at the women, كمان most of the lines are going up, 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 with the exception of this line. Obviously, it's going down towards for the last period, يعني recently. كمان this is the same age group, 16 to 24. But also, if you try and look carefully, you'll see that also this line starts to go down, and this is the 20 to 25 to 35 years of age, and this is what we just mentioned right here. Okay, so when it comes to treatment, the prevalence of receiving the antidepressant is increasing over the years, over the age group and gender. When they started looking at the outcome in the suicides or other health outcome, they noticed that the suicide rate and non-drug poisoning declined steadily from 1993 to 2004. Antidepressant poisoning mortality rate had a slight increase from 1996 to 1997, followed by a decline, like an overall SARFI decline. And the final conclusion was increased treatment with antidepressant was not associated with antidepressant poisoning mortality or suicide in England at a population level. Okay, so that was a nice example of looking at morbidity data and prevalence over the years to see how these things are related. The last thing we will discuss in this chapter is mortality, the measures of mortality. So again, you have seen this before in public health, and this is just a very brief reminder. Crude mortality, you're looking at everybody that died, regardless of what they died of. Specific mortality ratio looks at a specific subpopulation. It could be disease specific, it could be age specific, gender specific, or race specific. Adjusted mortality ratio, this is where you adjust for age and sex, taking into account the distribution of the population, so that you can start compare between countries. Case fatality is how many of those with that specific disease end up dying, yani how much this disease is a killer. And proportionate mortality, out of everybody dying, how many died out of that specific disease. Now, the use of these mortality measures in pharmacoepidemiology. Cause-specific mortality has a great specificity, but there are uncertainties inherent in the assessment of the cause of death. Misclassification bias may be a threat to its validity. Misclassification is when you classify someone that was exposed بتحطوه منه exposed أو حدا exposed بتحطوه منه exposed. This is a misclassification, and we will talk about that more in details لما حنجي نحكي على cohort studies و case control studies والimpact of misclassifications. These all-cause mortality measures avoid the bias in the determination of the cause of death, but it lacks the specificity that cause-specific mortality measures provide. So when you're doing a study وتطلعوا على mortality in general, منا كتير impacted by misclassification لأنه خلاص حتى if you misclassified حدا died of heart who in fact he was died from something else, it doesn't matter. So it protects against misclassification, but منا specific. So preferably, cause-specific mortality should be reported alongside the crude mortality. You should look at both in pharmacoepidemiological studies. So here's an example. Retrospective cohort. Retrospective cohort, I hope you remember these words from 421, but we will look at them again in the coming lecture in much more detail. So retrospective cohort study looking at the non-adherence to medication and health adverse outcomes in diabetic patients. The non-adherence was assessed for 3 medications: oral hypoglycemics, antihypertensive with statin. The results: non-adherence was prevalent and associated with increased all-cause mortality and hospitalization. So هون فيكم تشوفوا كيف all-cause mortality was tied up to an exposure اللي هي non-adherence. وبما انه عم نطلع على all-cause mortality, then you don't worry too much about a DEFI misclassification, but you worry about, like, are they really dying out of this, or are they dying from something else? And so here's another case study, and in this case study, the drug studied was warfarin sodium, and which is used to prevent and treat thrombotic disorders. The common complication here, bleeding. The study involved several national databases. كمان عم نحكي على secondary databases. One is the National Prescription Audit Plus of the IMN Health for warfarin prescription. طلعوا between 1998 and 2004. A second secondary database كان ال FDA Adverse Event Reporting System for Serious Bleeding Associated with Warfarin between 1993 and 2006. Also, they looked at the National Center for Health Statistics website for the annual number of U.S. death events caused by anticoagulant between 1998 and 2004. And the National Hospital Ambulatory Care Survey for number of emergency visit with warfarin-related bleeding between 1999 and 2003. هلا ليه عم حط لكم اياهم هون not because I want to bore you, but because I want you to understand the importance of secondary databases in pharmacoepidemiology. يعني the data was already collected, the data was already there. All they had to do is get, and I say all they had to do, it's actually a very complex work. But my point being that they had to get the data and start analyzing the data, manipulating the data to get the results. So what did they find? They found that warfarin used increased 45%. Death attributed to anticoagulant as the underlying cause of death has increased from 0.45 per 100,000 to 0.52 per 100,000 among U.S. resident population. And the end was a recommendation by FDA to placing a black box on the product. So that concludes our lecture for chapter number 2. As I said, chapter number 2 is not finished. We will do further, we will look at the measures of association in a separate lecture.